Hello class, I'm Jackson Allred, and today we're going to be working problem number 4 in the exam 2 problems for videos. Now, problem 4 starts off with has multiple parts in it. The first part of problem 4 is write an equation for the combustion reaction. Okay, so we're given C2H2 and that's a gas. Make sure we put our states. And we're given O2, which is also a gas. And to find the products, we know if it's a combustion that the products are always CO2 and H2O. So we put CO2, which is a gas, plus H2O, which is a liquid. Now we need to balance this equation because it's obviously not balanced. So on this side we have two C's, we have two H's, and we have two O's. So on the other side we have one C, we have two H's, and we have three O's because there's two here and one here. So to start, we need to try to balance our O's, because our O's will help us to determine the rest. So, or actually, we can start with our carbons. So there's one carbon and there's two here. So if we put two carbons times this by 2, that makes this into 5 because there's 3, and if you just are timesing this one, that one still is a 1. So that makes this 5. Now, so we're still not balanced. If anything, we went further away. So there's 5 O's. So obviously 2 carbons isn't going to work. So probably it's just best to go ahead and double it, because when you double it, you can always determine whether or not if it needs to reduce down or not. So just go ahead and times this by 4. Now this is 9. So let's just go ahead and double it all the way throughout. So 2, let's put a 2 here. And if you put a 2 here, that changes this to 10. That's still 4. This is 10, and this becomes 4. So when we double on both sides here, 2, that becomes, these become 4 and 4. Looking balanced. So then in order to get 10 oxygen on this side, you need to times this by 5. So when we do this, even though we did double it, we realized that through doubling this, we can find how many O's we needed, and this balances our equation, and we don't have to reduce it any because this is the simplest it can get. Now, part B, we are trying to determine what is the limiting reaction, or reactant, sorry. So we are given 15 grams of C2H2 and 20 grams of O2. Now, in order to determine the limiting reactant, we are going to try to get this from grams of C2H2 to grams of H2O. Because in order to determine the limiting reactant, you have to determine which one is the least amount in grams of H2O. That will give you the limiting reactant. So, to start off with C2H2, the molar mass of C2H2 is 26.04 grams of C2H2 over 1 mole of C2H2. So that cancels out our grams, and now we're at moles. Next, we have to get from moles of C2H2 to moles of water. In our balanced equation up above, for every 2 moles of C2H2, there is 2 moles of water, or H2O. That cancels out moles of H2O. Now we need to get from moles of H2O to grams of H2O. So in 1 mole of H2O, there are 18.02 grams of H2O. Now we have it at grams of H2O. So now we have to put this in our calculator, and that will give us 10.4 grams H2O. Now, we still have to determine if oxygen is the limiting reagent or not, so we still got to do this one down here. So next we do the same process. We go to molar mass. We do 32 grams O2 over 1 mole of O2. And then in 5 moles of O2, there are 2 moles of H2O. And then we got to get to grams. So in 1 mole H2O, there are 18.02 grams H2O. You get 4.50 grams of H2O. So seeing how oxygen's number is lower than C2H2's number, that means this is the limiting reactant. So oxygen, O2 is our limiting reagent. Now, we still have to do part C, and that is how many of each reactant and product are present after the reaction. So right away, we already know on the reactant side, we know that we know that on the reactant side, that oxygen, since it's the limiting, that means there's 0 grams of it being used, because it's already been used all the way, or after, there's 0 grams of it after the reaction because it's already been used up. We still have to determine grams of C2H2, and we still need to determine on the product side. Well, actually, no, we don't have to determine, we only have to determine CO2, because we know that the limiting reactant is 4.50 grams of H2O for the product side. So we just have to determine grams of CO2. So let's start off with our grams of CO2. So we are given, in order to find the grams of CO2, we take our limiting reagent, we take our limiting reagent, we put it down here at the bottom, and we go from grams of O2 to grams of CO2. So there's 32 grams of O2 in 1 mole of O2. And then if we remember in our balanced equation, in 1 mole of O2, on the balanced equation side, there are 5 moles of O2 in 2 moles of CO2. And then now we have to determine, since we're at moles of CO2, we got to get to grams. So in 1 mole of CO2, there is 44.01 grams CO2. Now we can write that down we can plug that in the calculator, and that gives us 22.0 grams of CO2. So since we did that with the limiting, this is what's present after the reaction. There's 22.0. Now we have our CO2, so now we need to try to determine how many grams of our excess reagent, or C2H2, is left over. So we want to take our product and go in reverse. So in the 4.50 grams of H2O, we want to go from grams of H2O to grams of C2H2. So in 18.02 grams of H2O, there is 1 mole H2O. And then in 1 mole of H2O, in the balanced equation, there are 2 moles of H2O in 2 moles of C2H2 using the ratio. So we are now at moles of C2H2, so we got to get to grams. So in 1 mole of C2H2, there is 26.04 grams of C2H2. Now we can plug that into our calculator, and we get 6.50 grams of C2H2. Now this isn't the excess, this is what was used. So in order to determine how much is left over, we got to take what we were given and subtract it from what was used. So we were given 15 grams. So we want to subtract that from the 6.50 grams, and that's going to give us our excess. So there are 8.50 0.0 grams of C2H2 left after the reaction. That gives us our final answer. All right, well, thank y'all for sticking in there with me. I know I was probably hard to listen to, but thank you for sticking with me. Y'all have a good night.